Here we go. So today, guys, we've gone over the test. We want to probably talk about notes on chapter 1.4, right? Dimensional analysis. All right. The unit that we're about to start on here, guys, covers 2 chapters. Covers parts of chapter 1 and parts of chapter 3. All right. So converting units is going to be what we're going to focus on for today and tomorrow, probably. We'll get into significant figures. I think I mentioned that yesterday, and scientific notation later this week. Okay. So this is chapter 1.4. And mostly this is just a kind of a reminder from last year how to do dimensional analysis. Okay. So typically in a dimensional analysis problem, which we do a lot in chemistry, you wind up getting told some equality. Let's see if I can get this thing to work well. All right, so we get told some equality, or we might have to know some equality, and we're asked a question. Okay. The particular question we got here is, what is the mass in pounds of a human with a mass of 75 kilograms? So they want us to take 75 kilograms and convert that into pounds. The way I suggest doing dimensional analysis problems is always to start with the given, what you know. In this case, we know we've got 75 kilograms, right? We're going to multiply that by some factor. And eventually, when we're at the very end of multiplying it by a factor or more than one factor, we're going to want an answer of pounds. Is this ringing some bells for you guys?
Yeah.
Okay. And the way we do this is through converting units, dimensional analysis, analyzing the dimensions, analyzing the units. Basically, the rules are pretty simple. Whatever the units are that you start out with, you want to cancel them out and get rid of them. The way to do that is to have those units be on the bottom of the next factor. Okay. Seems I'm having some trouble with my little thing here. There we go. Okay. So since kilograms was at the top of this unit, and I want to get rid of it, I'm going to have it at the bottom of this unit. Can I convert kilograms into pounds? Can I convert kilograms into pounds, guys? Yeah, sure we can, right? Okay. They tell us right here in the problem. 1 kilogram is 2.205 pounds. Notice I always put my units in first because that helps me guide where those numbers go. Kilograms is on the bottom. The number up here says that 1 kilogram should go on the bottom. So I'm going to put 1 on the bottom. I'm going to write it exactly like they wrote it, 1.00. And I'm going to put pounds on top. So I'll put 2.205 up on the top here. Okay. That means kilograms and kilograms wind up canceling each other out. The only unit I'm left with is pounds. And that's what I wanted. So I'm going to write an equal sign. From here, it's just a matter of doing the math. Did you guys bring your calculators?
No.
Yeah. If not, you want to start bringing your calculator, right? Okay, I signed the homework. It says we need to do calculations. The smart thing to do is bring your calculator. Okay, remember, non-graphing calculators only for tests, so you probably want to make sure that you're bringing only non-graphing calculators to class for practice. Okay. So 75 kilograms times 2.205, and then this also says divided by 1. Do we need to divide by 1 in our calculator?
No.
No. We know that when we divide by 1, it's going to be the same thing. Okay. So what sort of answer am I getting here? All right, 165.375. Okay. Were there more numbers in the calculator? That was it? Okay, so we'll just write them all down then. We get 165.375. Questions about that, guys? If you don't have questions, let's try that. Let's get you to do this one. Okay. Take a moment. Okay, so the way to solve this problem, pretty simple. looks like most of you guys have this. We start with 210 pounds. What units go on the bottom of this conversion?
Pounds.
All right. What units go on the top? kgs, right? So what number goes on the bottom with pounds?
2.205.
Aha, 2.205. And what number goes on top of kilograms? 1.00. Right? What happens when we take 210 and we multiply it by 1 and then divide by 2.205? Jason, what'd you get? All right. What units should be on this answer? kgs, right? Okay. Now, guys, all answers should have units on them, right? If you write down a number, make sure you write down a unit on it. Because if you write down an answer at 12, what do I think you're talking about? Yeah, the number 12. Could be anything, right? Could be 12 students. It could be 12 dozen eggs. It could be 12 erasers. 12 Big Macs. Right? Okay, I'll stop talking about food then. All right. All right. So sometimes, guys, you wind up having to convert with more than one step. Okay. Sometimes it's easier to wind up using multiple conversion factors rather than figuring out what the equivalency is to go between 2 or 3 steps in one step. Okay. This way you only need to memorize a couple of conversion factors rather than to have a whole bunch. So here's the example of using multiple steps. All right. Length of a marathon race is approximately 26.2 miles. Since we know that 1 mile is 5,280 feet and there are 2.54 centimeters in an inch, what is that distance in meters? Does this sound like a fun problem?
Yeah.
I think so. All right. The way we're going to work this out is we're going to start in the same place that we always start. They gave us a value that they want us to convert. By reading the text, it says 26.2 miles is what they want us to convert. What do we want this unit to be in at the end? Meters, right? It starts out in miles, and notice miles is MI. At the very, very end, I want it to be in meters, which my pen's not working very well. I don't know what's wrong with it today. All right, so we want it to be in meters. So we're going to do this conversion. The first conversion that we can do, we know that miles has to go on the bottom. That's kind of given, right?
Yeah.
Okay, always, always, always start with what you're given. We started with miles, so miles has to go on the bottom. What can I convert miles into?
Feet.
All right, so I can put FT on the top. It looks like 1 mile is 5,280 feet. Okay, I'm not done yet though, so we've got to do another dimension. What has to be on the bottom of this dimension? Feet, right? So this conversion factor has feet on the bottom. What could I convert feet into that's going to be useful? Do I know how many centimeters there are in a foot?
Yeah.
We do? How many centimeters?
Inches.
Okay, inches. All right, we know how many inches are in a foot. So I know 12 inches are in a foot. That's something that we learned way back when, right? What was that, first grade? Maybe before that? Okay, we're still not done. We've got inches, but we want meters, so we've got to do another conversion factor. Inches has to go down here. What has to go on top? Centimeters. We know this. They told us, right? 1 inch is 2.54 centimeters. Inches and inches cancel. Still not to meters, though. So we got to go from centimeters to meters. Uh-oh. You guys know how many centimeters? Which is bigger, a meter or a centimeter? Meter, right? Okay, so I'm going to put a 1 on meter. How many centimeters are in a meter? It's not 1,000. Think about cents. How many cents are in a dollar?
4.
How many cents are in a dollar?
100.
100, right? Okay, so how many centimeters are in a meter? 100. You know that prefix cent
Yeah.
in centi? It actually has some meaning, and we use it regularly when we use money. Okay, so centimeters and centimeters cancel. We get meters. Hey, meters is what we wanted at the end, so we can write an equal sign. Now here's the math. The math you need to follow along with in your calculator. 26.2 times 5,280 divided by 1 times 12 divided by 1 times 2.54 divided by 1 times 1 divided by 100. Jason, you got an answer for us? 8128. How many other people with calculators got that? Nice. All right. Very good. Okay, so this is the last problem we'll do today as a group. And notice it's going to be a little bit tougher. I'll explain why in a second here. They say the orbital speed of Earth is 29.8 kilometers per second. So the satellites that are moving and orbiting around Earth in 1 second move 29.8 kilometers. That's a pretty good distance, isn't it? 29.8. And I'm going to write this a certain way. I'm going to write kilometers per second. Could you guys agree with me that that's okay to do? Okay. 29.8 kilometers per second means the same thing whether you write the per as a diagonal or as a horizontal. Since we use horizontal slashes in dimensional analysis, it's going to be a lot better to have a horizontal slash. Okay. What units do we want to convert to? Miles per hour, right? So it's in kilometers, we want it in miles. It's in seconds, and we want it in hours. How many units do we have to convert? Okay, guys, try this again. How many units do we have to convert? 3? 4? How many units are there? There's kilometers and there's seconds, right?
2.
Both of them need to be converted. So how many units do we need to convert? 2. All right. All right, so we got to get kilometers and seconds. Let's tackle kilometers first, because that's what we've been doing previously, right? We've been tackling the units on top. So kilometers, I'm going to put on the bottom. What units do I want to convert kilometers to? Miles, right? Okay, and they've got a conversion factor for me up here. 1 mile is 1.60934 kilometers. Kilometers is going to cancel kilometers, and I'm going to wind up with an answer that's in miles over, and the units that are on the bottom still are seconds. Is that going to be okay, or do I need to do another conversion? One more conversion, right? So this one's a little bit different, right? Seconds is on the bottom, so where do I have to write seconds in my new conversion? Top, all right? You guys are awesome. What do I have to write on the bottom? All right. Do I know how many seconds there are in an hour? Does anyone know? We could look it up, or we could figure it out, right?
Yeah.
Okay, real quickly. How many minutes in an hour? How many seconds in a minute? 60 times 60. 3,600 seconds. Okay. Now, if you didn't know that, or if you couldn't figure that out, how many steps would you have to take here? 2. You'd have to convert hours to minutes and then minutes to seconds. But we were able to figure that out. So seconds will wind up converting seconds. That's going to leave us with miles on top and hours on the bottom, which is what we wanted. So we're going to be able to do the calculation now. 29.8 times 1 divided by 1.60934 times 3,600 divided by 1. All right, Jason, what do we get? 66,000. Say that again. That's probably enough, right? 66,660 miles per hour. So in 1 hour, something that's traveling in orbit around the Earth is traveling 66,000 miles. That's pretty fast.